हेलो माय डियर मैकेनिकल एंड सिविल इंजीनियर्स, व्हाट्सअप, कैसे हैं सब लोग। ए वेरी वेरी गुड मॉर्निंग ऑल ऑफ यू एंड ए वेरी वार्म वेलकम टू यू ऑल to this wonderful session of fluid mechanics. So please guys do join me fast so that we can start this session. So the series is 10 ka dam, in which we are discussing the most wonderful 10 questions, only 10 questions from each and every chapter of fluid mechanics. We have already discussed the questions from fluid statics. We have already had a session for the kinematics yesterday, and today we will be having some beautiful numerical practice for the subject of fluid dynamics, and one of the important topic in your GATE examination. So those who are watching me live, please do respond through the comment section if my audio and visual quality are fine, so that we can start this session at the earliest. All right. So I hope you have revised your fundamental, you have brushed up your fundamentals so that you can involve yourself in the session to the best possible and gain the maximum out of this session. Right. So dynamics means Bernoulli equation. What I will be discussing here in today's session will be the numericals from the Bernoulli equation and its application. I will not going to touch the real flow. I will not be talking about the real flow. Laminar and turbulent will not be part of today's session. Tomorrow we will be having another session for completely dedicated to the real flow. Laminar flow in a pipe, turbulent flow in a pipe, compound pipe system, as well as the boundary layer theory. Everything related to the viscous forces in the flow will be discussed in tomorrow's session. All right. Hi Maniket, welcome, good morning. आप उठ जाते हैं संडे को इतना जल्दी? 11 AM is not that early, right? And if you are students sincerely preparing for your examination, you should get up not beyond 6 AM or 6 to 7 AM. You should keep it a habit that you should get up early in the morning and you should sleep on time. That is what the routine, ideal routine should be followed. All right. So let us start our session. Keep on sharing your doubts, keep on sharing your knowledge through the comment section. But first of all, those who are here, please mark your presence by showing some love, affection, and by writing anything in the comment section. So this is my quick, short, simple introduction for those who are attending my session for the very first time. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi, graduated in 2006. I have also cleared engineering services examination, IES, which is conducted by UPSC, and I had worked in Steel Authority of India Limited for a couple of years, and from last 11 years I have been into teaching, completely into teaching, guiding the students who are preparing for various competitive examinations. So these are my favorite subjects. If you have any doubt in any of the mentioned subject, let me name those subjects: fluid mechanics, entire thermal engineering, thermodynamics and its application, heat transfer, and industrial engineering. If you have anything to ask, any doubt in any of these topics, you can always connect with me through the mail ID chandra.shekhar7@byju's.com, or you can join me on the Telegram scanning the QR code or using the link which is mentioned at the bottom. Where are others? Maniket, please do share the link of the session to all your friends, colleagues who are either civil engineers, who are in civil branch or mechanical engineering branch, because more and more students will join, then only the session will become interesting and energetic. So these are the various things you will be getting once you join me on the Telegram. The notification of the various examination we will provide you through the Telegram channel. The PDF of this session as well will be shared with you through the Telegram channel, and the study notes. People keep on asking about the study notes. We will share the study notes, updates of the various session, the upcoming sessions, and important information, important announcement, as well as the important questions and doubt resolution are going to happen through the Telegram channel only. All right. So there is an important announcement to be made before we start our session on this 25th of October. For those students who are targeting GATE 2025, those who are in their third year or in second year even, so for those students who are not appearing for 2024 but they are planning to prepare for 2025, Richa ma'am will be having an important interactive workshop where she will be discussing about the preparation strategy to clear the GATE 2025 examination. You just have to register yourself, and the link to register yourself is already there in the description box. All right. So do not forget to attend this workshop. Definitely, believe me, it is going to be very beneficial for your efficient preparation. And today only there is scholarship test going on. You can attempt the scholarship test anytime between 9 a.m. to 9 p.m. Tomorrow so results will be announced tomorrow. Based on your performance in the scholarship test, you can get our various courses on the discounted prices. All right. So let us start our session. Question number 1. Please keep your pen, notebook and calculator. Sit back, relax and enjoy this session. The first question is there on the screen. Everyone, please give it a try and let me see who will be the one giving me the correct answer. Read the question carefully. All the questions are based on either Bernoulli equation or the application of momentum equation, means ideal flow. Today's session is all dedicated to the ideal fluid flow. All right. बाकी लोग क्यों नहीं रेस्पॉन्ड कर रहे मुझे पता भी नहीं है कि there are so many students who are there, but I don't know what are the names of the students who are there part of my session. So please do write in the comment section. Introduce yourself, mark your presence. These are the important or basic things I can expect from you guys. Maniket solve कर रहे हैं इसको? Are you solving the question? बाकी लोग, please give it a try. A nozzle has an inlet and outlet diameters of 10 centimeter and 5 centimeter respectively. Inlet diameter of the nozzle is a gradual converging section. This is inlet section 1. This is the outlet section 2. So the diameter D1 is equal to 10 centimeter and D2 is 5 centimeter, right? If the discharge of air, the fluid is air and the discharge of air is 0.1 meter cube per second, Q is given as 0.1. Q is equal to 0.1 meter cube per second into the atmosphere. It means P2 gauge is equal to 0, isn't it? The gauge pressure at the nozzle inlet. What is the value of gauge pressure at 1? Simple question. So how to solve it? There are two basic equations, fundamental equation to be applied between point 1 and point 2. Point 1 is inlet, point 2 is outlet. That is the continuity equation. Apply the continuity equation between 1 and 2. If we apply continuity equation, mass conservation equation, we are assuming the flow to be steady, incompressible and 1D. So discharge, which is equal to A1 V1 is equal to A2 V2 remains constant. That is the continuity equation. From here we can say D1 square into V1 is equal to d2 square into v2. So we can say d1 v2 becomes 4v1, isn't it? If we put the value, d1 is 10 centimeter, so it will be 10 square into v1 is equal to 5 square. 5 square into v2, so v2 is equal to 4v1, isn't it? And how to find out v1? How to find out v1? Can we find out v1 from this expression only? v1 is equal to 4q by pi d1 square. What is the value of v1? What is the value of v1? 4 into 0.1, take care of the unit, pi into diameter is given in centimeter, so 0.1 whole square. So 0.1 getting cancelled out. Then what is the value of v1? That is 4 by 0.1 pi or 40 by pi. 40 by pi meter per second. What is the value of v1? Those who are live, it does not cost you anything. If you write something in the comment section, it will not cost you. We will not force you to join our paid courses. Don't worry about that. 12.37. V1 is equal to 12.37 meter per second. It is not a pravachan. It is a practice session. So the more you involve yourself, the more benefit you will get. And now apply the Bernoulli equation. If we write the Bernoulli equation, we can write the Bernoulli equation in terms of pressure also. We can write the Bernoulli equation in terms of pressure also. क्या बता रहे हैं मनिकेत, आप बता क्या रहे हैं? You should mention कि आप किस चीज की वैल्यू बोल रहे हैं. Is it your final answer 12.5? और velocity बता रहे हैं 12.37, right? If we apply Bernoulli equation between 1 and 2 in terms of pressure, so we can say P1 plus rho g z1 plus rho v1 square by 2 is equal to P2 plus rho g z2 plus rho v2 square by 2. And the nozzle is having the same potential energy at inlet and outlet. Let us assume the nozzle is having same potential energy. P2 gauge, if we take, the question is to find out P1 gauge. So P2 gauge will be 0. So gauge pressure at 1 is simply rho by 2 V2 square minus V1 square. And V2 is equal to 4V1. So it will be rho by 2 into 4V1 square minus V1 square, isn't it? So that will be equal to rho by 2 is equal to 16V1 square minus V1 square, so it is 15 V1 square. So if you put the value, what is the density of air? The fluid is air, density is given as, density is not given. Density is not given. If we take density as 1.23 by 2 into 15, 12.37 whole square. What will be the answer? What will be the answer? If we take density as 1.23 into 15 into 1.23 divided by 2. It is 1495 in Pascal. In kilopascal it will be 1.4955. Isn't it? It is something around 1.49. It will be 1.49. Isn't it 1.49 something? So the nearest option will be treated correct. If it is not given, we can take 1 or 1.23 like that. If the density of air is not given, we can take the standard value. It is around 1.23. Density of air is, atmospheric air is 1.23. Air to be considered as incompressible fluid, isn't it? So the correct answer is option B. If you have any doubt, you just let me know. But do practice. Is it 1419.85? So 1.42. So anything around 1.4 will be treated as correct answer. So the answer will be 1.46. I hope you got it. क्यों? Density of air is having a standard value 1.23 kg per meter cube. इसलिए ये वेरिएशन आ रहा है कि थोड़ा अगर 1 लेंगे तो there will be a different value, 1.2 लेंगे तो there will be a different value, and if you will take 1.23 then it will be slightly different value. All right, so this was our question number 1. Let us move to the question number 2. You should memorize the density of air. You should have an idea. Nobody else is going to respond. It is only Maniket and me who will be talking to each other. Question number 2 on the screen. Beautiful question. Try to solve the next one. Question number 2 solve करिए. Hi Yogesh, welcome. आप फ्लूइड कंटिन्यूटी इक्वेशन की बात कर रहे हैं योगेश. आर यू टॉकिंग अबाउट कंटिन्यूटी इक्वेशन या और कौन से फॉर्मूले हैं? अच्छा स्पेरिकल और मतलब पोलर कोऑर्डिनेट सिस्टम्स. अगर पोलर कोऑर्डिनेट सिस्टम से कोई क्वेश्चन आएगा तो इट कैन ओनली बी थ्योरेटिकल. न्यूमेरिकल यू डू नॉट एक्सपेक्ट. Numericals from the polar coordinate system is not expected. Only theoretical question can be asked, still very rare chances. But if you will have those equations in your notes and if you revise your notes, then you will come across those equations and automatically when you will see 4 options, you will be able to judge which of them is correct. Right? Polar coordinate system. So you do not have to solve a lot of numericals from polar coordinate system, but yes, a theoretical question can be framed. नहीं योगेश, टेस्ट सीरीज में अभी आपके पास there is no choice to demotivate yourself, there is no choice to lose your confidence. Test series are always on the higher side of difficulty level. Still you are not able to perform very well in the test series. Don't worry, find out those areas which you are getting mistake to be committed again and again. Observe those areas, improve them, work towards those areas, and do not feel disappointed because test series are always framed to make you prepare for the worst situation. All right. So polar coordinate system, they never had been asked. So very rare chances are there. Something can be framed from polar coordinate system. So you do not have to worry much about that. You should focus on those areas which are frequently asked from last 10 years, which are having more probability to be asked in the upcoming examination. All right. The next question, focus on the next one. Water flows through an open vertical cylindrical tank of 20 centimeter diameter. There is a cylindrical tank, open cylindrical tank of 20 centimeter diameter. Let me call it as capital D. Capital D is equal to 20 centimeter. Through a hole of 10 centimeter diameter, there is a hole of 10 centimeter. Here there is, let us say, a hole, and the diameter of the hole is, let us say, 10 centimeter. Small d is 10 centimeter. And the level of water, the height of water, let me call it as h. What will be the velocity of water flowing out of the hole? What is the velocity of the water flowing out of the hole? At the instant when the water level in the tank is 50 centimeter, H is 50 centimeter above the hole. Ignore the unsteady facts. What is the answer? Can you solve it? So again apply the continuity equation between 1 and 2. Where are 1? Where are 2? Point 1 is at the free surface. Point 2 is at the outlet of the hole. If we apply continuity equation between 1 and 2, if we apply continuity equation between 1 and 2, here students commit mistake. Yogesh, that is what people commit mistake. What people do is they always remember torsal equation. Are you guys aware about torsal equation? V is equal to root 2 GH. Are you guys aware about torsal equation? If we apply Bernoulli equation between 1 and 2, we get torsal equation, right? By applying the Bernoulli equation between 1 and 2, P1 is equal to 0 and P2 is also 0. Gauge pressure, both are in contact with the atmosphere. Z1 is equal to H, here Z2 is equal to 0. V1 is equal to 0, we assume, and V2 is equal to unknown. So there we use this. What is the answer? Under root 2 into 9.81 into 50 centimeter to be converted into meter, that is 0.5. So under root of 9.81, root of 9.81, isn't it? .13. That is what people do. Let me tell you, this will not be correct. Why? Because the diameter of the cylinder is not infinite. When we have the diameter of the cylinder very large compared to the hole, then we assume the velocity to be 0 in the cylinder. Now here the velocity in the cylinder will not be taken as 0. Are you getting it, Yogesh? Questions ऐसे frame होंगे. The questions will be framed this way. That is why I am asking you to apply the continuity equation between 1 and 2 first. समझ में आया कि नहीं? Please acknowledge it. Please write yes in the comment section. Please show some love, affection. Please show some heart sign in the comment section if you understood the logic that why we are not using the straightforward torsally equation in this question. Because the diameter of the cylinder is 20 centimeter, whereas the diameter of the hole is 10 centimeter, right? So there the questions are framed this way in your GATE examination. So continuity equation if we apply, so we can say d square into V1 is equal to d square into V2, and the diameter is capital D is twice of small d. So simply we will get V2 is equal to 4V1. We will get V2 is equal to 4V1. Our objective is to find out the value of V2. V2 will be equal to 4V1, isn't it? V2 will be equal to 4V1. That is what we need to calculate. Now, if we apply Bernoulli equation between 1 and 2, if we apply Bernoulli equation between 1 and 2, then we will get, if we apply Bernoulli equation between 1 and 2, then we will say P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g. I told you Z2 is equal to 0, that is the reference line. Z1 is equal to H. P1 and P2 are equal. P1 is equal to P2 is equal to gauge pressure, or P1 is equal to P2 is equal to gauge pressure 0, and Z2 is equal to 0, Z1 is equal to H. So from here we can say V2 square minus V1 square by 2g is equal to H, or we can say V2 square minus V1 square is equal to 2gh. What is V2? 4V1. So this is 15V1 square is equal to 2gh. V2 is equal to 4V1, 2gh. So what is the value of V1? That is under root 2gh by 15, isn't it? यहाँ कुछ गड़बड़ की है मैंने? Did I make any mistake here? Did I commit any mistake? The question is to find out, sorry, the question is to find out V2. I made a mistake. We are calculating V2. We are not calculating V1. So do not write here. What we need to do is calculate V2. If you are calculating V1, then we can calculate V2. One and the same thing. सही था, ठीक था. 15 V1 square minus is equal to, ठीक तो था, is equal to 2GH. So V1 is equal to under root of 2GH by 15, and V2 will be equal to 4 times of V1 under root 2 into 9.81 into H is 0.5 upon 15. Can you solve and let me know the answer for V2? Can you find out the value for V2? What is the answer? 2 into 9.81 into 0.5 divide by 15 and take the square root of this multiplied by 4. It is 3.2348. 3.2348 meter per second. So the one which is nearest to your answer will be treated as correct. 2.55 क्या आया Maniket? What is this 2.55? I hope you guys understood. Is there any doubt? Everybody else, you guys are most welcome to discuss with me, to communicate with me in case of any doubt, in case of any suggestion. If you want me to repeat, I can repeat the question again, but I want your participation. Don't forget, the expert in anything was once a beginner. So even if you are not very much comfortable, start now, practice, revise, try to work hard. Definitely you will become the expert in the subject. Let us move to question number 3. The next question, beautiful, simple, interesting question. Beautiful question. Question number 3 on the screen. Everybody, please do give it a try. A 20 centimeter diameter pipe carries a water discharge of pi by 100 meter cube per second. The discharge is given as pi by 100. Yogesh, now you should focus on appearing for the test only. You should do your revision through the mock test only. We have started mega mock test. Didn't I tell you? This is the schedule. You should appear for these tests, and accordingly you should revise your basics. This is for mechanical actually. Similarly, there must be a schedule for civil. Yes, Yogesh. First appear for subject wise. Topic wise is nothing. There is nothing called topic wise test. You should have the subject wise test. For an example, like this, you should plan your practice sessions like this only. First of all, general aptitude, engineering, mathematics, thermodynamics and heat transfer, then fluid mechanics, strength of materials, etc. Then your technical subjects, and then you should start appearing for the full mock test. In December, you can start appearing for the full mock test. This is the ideal timetable you should follow. All right. We were here. So the pipe is bent through an angle of 30 degrees. It is in a horizontal plane. The bend is in a horizontal plane. The question is from the momentum equation. The question is from the momentum equation. In a horizontal plane as shown in figure, neglect the friction. It means ideal flow. The component of the force exerted by the water. The question is the force exerted by the water. on the bend in x and y direction respectively are. There are two types of options. One is the numerical. In some of the options, numerical values are same. A and B are having same numerical values. The change is only with the sign. A, B and D are having the same numerical values, but only the change in the sign. Similarly, C is having a different numerical value. So the direction as well as magnitude both are going to play an important role in this question. It is not only about the magnitude, the direction is also going to be very, very important. Wow, Maniket, great. तो अगर आप थोड़ा सा स्मार्टली अप्रोच करें इस क्वेश्चन को, बिकॉज इफ यू सी ए बी एंड डी, options A, B and D are having the same numerical value, only the difference is of the sign. So let us try to find out the direction first. Let us first try to find out the direction. If that will help us to get the correct answer, then nothing like that. If that will not help us to get the right value, then what we will do is we will write the momentum equation to find out the magnitude. So this is the positive x direction and this is positive y direction. So whenever the fluid is entering and leaving like this, whenever the fluid is entering and leaving like this, the fluid will exert a force on the walls of the pipe which is normal and compressive. This is how the fluid is going to exert a force on the pipe walls, isn't it? On the inner side and the outer side, the fluid will exert a force like this. And the pressure, let me call it as 1, let me call it as 2. The pressure on the inner surface is less than, or let me call it as I inner and let me call it as outer. Pressure on the inner side is less than pressure on the outer side, and the area of the inner wall is less than area of the outer wall. Pressure and area on the inner walls will be less than outer walls. So can we say, so force on the outer wall will be greater than force on the inner wall. Force is equal to pressure into area. So the force on the outer wall will be greater than force on the inner wall. So we can say the net force will be on the pipe, the net force will be something like this. That is the net force on the pipe by the fluid. So it will have positive x component and it will have negative y component. It will have positive x component and negative y. So the one which will be having, that is the force, direction of force exerted by the water on the bend. So force on the bend, it will have positive x component and negative y x component. So positive x and negative y. B cannot be correct because it is having negative x and positive y. C cannot be correct because it is having positive x and negative y. Yes, C can be true. C can be true. B cannot be true. D cannot be true. So B and D cannot be true. It can either be A or either C, isn't it? It can either be A or C. Now write the momentum equation to find out the value. So if we write the momentum equation, this is, let us say, Fx. This will be Fx. So on the fluid, so this is on the pipe. Now on the fluid, this will be the direction of resultant force on the fluid, on water. This will be the direction of resultant force on water, isn't it? So force on water, that is Fx, and force on water, that is Fy. So if we write the momentum equation, we can say P1A1 minus Fx, then P2A2 cos 30 minus P2A2 cos theta is equal to, that is the force on the fluid. So fluid change in momentum, that is rho into Q into change in velocity. Final velocity is V2. So it is V2 cos theta minus V1, isn't it? Minus V1. Because P1 and P2 are equal. Here P1 is equal to P2, Z1 is equal to Z2. So we can say V1 is equal to V2. And what is the value of V? That is 4Q by pi d square. Velocity will be equal to 4Q by pi d square. V1 will be equal to V2. So these two will get cancelled out. P1 is equal to P2 is 0 because P is PATM. These two terms will be getting cancelled out, and we can say Fx force on the fluid will be equal to rho into Q into V cos theta minus 1. So it will be rho QV then 1 minus cos 30. Put the values, you will get the answer. So it will be rho Q then 4Q by pi d square into 1 minus, what is cos 30? What will be the answer? Are you getting it? Under root 3 by 2. Put the value, that is 10 to the power 3. If it is in kilo, it is in Newton only, na? Into 4 into Q square. What is Q? Pi by 100. So pi square by 100 square into pi into d square. What is the diameter? 20 centimeter. 0.2 square into 1 minus root 3 by 2. Can you solve it and let me know the answer? Or it would have been better if you could have solved Fy. Fx is a little difficult. Let us talk about Fy. Let us talk about Fy. This is Fy. And this will be 0. P1, A1 will be 0. P2 will also be 0. So we can say Fy in y direction 0 plus Fy minus P2 A2 sin theta is equal to rho Q into change in velocity, initial minus final, sorry, force on the fluid. It will be final minus initial. Final velocity is V2 sin theta minus initial velocity will be 0 in y direction. Initial velocity will be 0. This to be 0. So Fy is equal to rho QV into sin 30. That will be Fy. Rho is 10 to the power 3 into Q, that is 100 by pi into 4 into 100 by pi 4Q by pi d square. Pi d square. Diameter is 20 centimeter. 0.2 into sin theta. Sin 30 1 by 2. That is Newton. Can you solve it? Can you guys solve it? This pi will get cancelled out. Sorry, this will not get cancelled out. It will become pi square. So there will be 1 pi only. What is the answer? Or better, you should find out the value of V. 4 into 100 by pi upon pi into d square. What is the value of velocity? If you find out the velocity, then it would be better. 400 divided by pi cube, pi square. Pi square divided by 0.2 square. So 1013, velocity is 1013. 0.2 meter per second. The velocity is 1013.2 meter per second, isn't it? It is pi by 100. उल्टा किए जा रहा हूं ना मैं बार बार, सारा सब कुछ गलत कर दिया. Velocity is how much? First of all, it is always better you should do your calculation step by step. That is the learning for me as well. That is the learning for me. Don't write so many things. First of all, calculate the velocity. It will give you 4q by pi d square. That is the velocity. 4 into q is pi by 100. Pi by 100. And then pi into d square. So pi and pi will get cancelled out. So it will be 4 upon 0.2 square is 0.04 into 100. So it will be 1 meter per second. Velocity is 1 meter per second. What is the velocity? Are you getting velocity as 1 meter per second? If you are getting velocity as 1 meter per second, then it will be simple. Then it will be simple. So rho is 10 to the power 3 and Q is equal to pi by 100. It will be pi by 100 into 1 into 1 by 2. So it will be pi upon 10 pi upon 2. 5 pi Newton. Isn't it 5 pi Newton? 5 pi. The value is 15.7. 15.7 is Fi. The value is 15.7. So that is why A is the correct answer. A will be the right answer. Similarly, you can find out Fx. Similarly, you can find out. मनिकेत, आपने A कैसे find out किया बड़ा जल्दी? आपने A कैसे find out किया? So fast. इसको सॉल्व करेंगे, इसको भी सॉल्व कर लीजिए, Fx को भी सॉल्व कर लीजिए अगर अब हो गया तो। 4q रो QV, Q की वैल्यू है पाई बाई 100 इंटू 1, तो ये हो जाएगा 1000 बाई 100, 10 पाई इंटू 1 माइनस रूट 3 बाई 2 न्यूटन। इसको सॉल्व कर लीजिए, अंडर रूट 3 बाई 2, 1 माइनस आंसर इंटू 10 पाई 4.2। डायरेक्शन मैंने ऑलरेडी आपको बताया था, Fi सॉल्व कर लिया था। सो 4.21 is Fx and 15.7 is Fy, राइट। डायरेक्शन मैंने आपको ऑलरेडी बता दिया था। डायरेक्शन, फोर्स ऑन द फ्लूइड होता तो डायरेक्शन ये होता, एंड फोर्स ऑन द पाइप होगा तो डायरेक्शन ये होगा। The question is to find out the force on the pipes. That is why the direction is this. Question is beautiful. The next question is again important, beautiful question. Question number 4. The next question, give it a try, every one of you. Question number 4. Find out the answer. Air from a blower of a hair dryer blows between two identical elliptical cylinders suspended freely. For two cases shown in the figure, the cylinder would move. In first case and in second case, what is your opinion? That is conceptual question. Yes. Can you try? Can you give it a try and let me know the answer? बताइए, what is your opinion? Look, there is a slight difference between case 1 and case 2. What is the slight difference between them? Here in case 1, it is a gradual convergence. It is like a nozzle. There is a gradual convergence. And here it is a sudden convergence, that like restriction. Here it is a sudden convergence. It is like a sudden convergence. In second case, it is a sudden convergence. What is the answer? Gradual convergence and sudden convergence. The streamlines will be like this. In first case, the streamlines will be like this. In second case, the streamlines will be like this. So here if you see, area is continuously decreasing, so velocity will increase, so pressure will decrease. At the middle, the pressure will decrease, so the fluid will exert a force from high pressure to low pressure, so they will be brought together, come closure, isn't it? In the first case, the ellipse will come closure, but here due to sudden convergence, it is a sudden convergence, so the fluid will strike here, the fluid velocity will decrease, here the velocity will decrease and the pressure will increase. If the pressure will increase, then they will move away from each other. Why the velocity will decrease? Due to restriction. Due to restriction. There is a restriction in the flow. If you have some restriction in the path of the fluid flow, the velocity will decrease. The velocity will decrease and the pressure will increase, isn't it? Because it is the static plus dynamic pressure. All the kinetic energy will convert into pressure energy. So the pressure in the gap will increase in second case, but the pressure in the gap is decreased. Pressure in the gap will decrease in the first case, and here pressure in the gap will increase in the second case. Are you getting it? That is why if the pressure is increasing in this gap, then they will move away. In the case 2, the ellipse will move away from each other, but in case 1, they will be coming closer to each other. Due to pressure difference, there will be force exerted in one case. In case 1, the force will be exerted towards the gap, but in second case, the force will be exerted away from the gap. So we can say in case 1, they will move towards each other for case 1 and away from each other in case 2. B is the correct answer. Yes, Maniket, B will be the right answer. Are you getting it? Have you understood the concept? If you liked this concept, this question, please do share this session to all your friends and do not forget to subscribe our BYJU'S YouTube channel if you have not done it yet. Tomorrow at 6 p.m. I will be discussing about the questions from the real flow, very important topic from the fluid mechanics for GATE, ESE and other competitive examination. Let us move to the next one then. This is the mock test schedule. You should appear for the mock test. It is the right time. You should start appearing for the mock test. You should start your revision parallelly. So you should utilize your next 3-4 months very, very judiciously to crack the GATE examination with the best possible score. So this is the mock test entire schedule, and based on your performance in this test, we will give you the access of our test series for the discounted prices. So it is helping you to improve your preparation through practice, as well as it will help you to open the door for other test series at a very reasonable prices. And you just have to register yourself, and the registration is free, and the link is already there in the description box. Let us move to the next one. Again, question 5 and 6. Question number 5 and 6 are again very, very beautiful question. Again from the momentum equation. This is also from the momentum equation. An incompressible fluid is passed through a T-junction supported on the wheels, as shown in figure. The area at the outlet A is twice that of B. Area at A is twice of area at B. That is shown from the figure itself. We can see it from the figure itself. If you see the area at A is twice of area at B, isn't it? It looks like that only. While the incoming mass flow rate is fixed, this is mass flow rate is constant. The incoming mass flow rate is constant. Right? The distribution of flow at the two outlet can be varied by a suitable mechanism built in the system. Assume that the flexible tube offers no resistance to the motion and frictional effects in the pipe and the wheel can be neglected. And now consider the following two cases. The case 1 says the flow rate at section A and B are equal. It means QA is equal to QB. In case 1, QA is equal to QB, and in case 2, the velocity at section A and B are equal. In first case, discharge is same. In second case, the velocities are same. Now the actual question starts. The first part of the question says, in case 1, the velocity at section A is twice the velocity at section B. In case 1, the velocity at section A is half. P and Q are about the velocity. Out of them, only one is correct. And R and S is about the flow rate. So can we say in case 1, if we talk about case 1, QA is equal to QB. What is QA? Area into velocity is equal to area into velocity, and area at A is twice of area at B. So twice of AB into VA is equal to AB into VB. So this AB getting cancelled out. So VB is equal to twice of VA. Velocity at B. In case 1, velocity at B is twice of velocity at A. In case 1, velocity at B is twice, or velocity at A is half of. So Q is the correct option. Q is the correct option here. And now if we talk about the flow rate in case 2, now let us talk about the case 2. Do you understand? This was case 1. This is case 2. In case 2, VA is given as equal to VB. So what is VA? That is QA by AA is equal to VB, QB by AB. Isn't it? What is AA? That is twice of AB. Area at A is twice of AB in both the cases. So QA upon twice of AB is equal to QB upon AB. AB getting cancelled out. So we can say QA is equal to twice of QB. QA is equal to twice of QB. QA is equal to twice of QB, isn't it? So in case 2, flow rate at A is twice that of B. R is correct. So Q and R are correct. Q और R तो है ही नहीं. एक्चुअली ये C नहीं है, ये Q है. ये Q है, C तो कोई ऑप्शन ही नहीं है. Q and R are correct, isn't it? So C is the correct answer. Are you guys getting it or not? Have you understood the logic or the concept? है तो सही है मनिकेत. सी तो कोई स्टेटमेंट ही नहीं है ना, 4 ही तो स्टेटमेंट है, PQRS, तो वो क्यू ही तो होगा, और क्या होगा? ऐसे नहीं बोलेंगे आपकी स्टेटमेंट ही गायब है. इज दिस क्लियर? जब अच्छे क्वेश्चन होते हैं तो मुझे लगता है 10 क्वेश्चन भी सॉल्व नहीं हो पाते हमें 1 घंटे में, बिकॉज वी नीड टू अंडरस्टैंड द इन डेप्थ कॉन्सेप्ट. Is this clear? Let us move to question number 6. Now it is your turn. Question number 6. The same. In case 1, the same information. In case 1, QA is equal to QB, and in case 2, VA is equal to VB. And in both the cases, AA is twice of AB. ये information given है. Now the movement of the system will take place. So how we will find out in what direction the movement of the system will take place? If we talk about this control volume, this is our control volume. This is our control volume. We will find out the force exerted on the control volume. Whatever the force exerted on the control volume will be equal to the force exerted on the system. This is the plate, let us say. Right? If we talk about case A, case 1, कौन सा स्टेटमेंट, कहां की बात करें आप? ये P स्टेटमेंट. इन केस 1, जो फर्स्ट केस है, देयर आर 2 केसेस ना, there are 2 cases. In case 1, velocity discharge remains constant, And in case 2, there are two different situations. In situation 1, discharge at A and B will be equal, and the statement, and in second case, the velocity is equal. Here, QA will not be equal to QB. And in the first statement, VA is not equal to VB. Are you getting it? So there are two different cases. In the first case, the velocities are not equal. In the second case, discharge are not equal. Getting it? Now, statement P says in case 1 where QA was equal to QB, then the velocity at section A is twice of velocity at section B. Is this statement correct or not? In statement Q says in case 1 when QA is equal to QB, then it says velocity at A is half of velocity at B. So out of these two options, which is correct? That is what I have told you. That is what I have told you here. If QA is equal to QB, then VB is equal to twice of VA. VB is equal to twice of VA. So statement Q is correct, not P. P will not be correct. Getting it or not? Right? Now about the momentum equation. Now if we talk about the momentum equation, now the question is about, this is about the momentum equation. The force exerted on the wheel will decide the motion. So it will be either in positive x direction or in negative x direction. The motion of the wheel or the motion of the system will either be in positive x direction or negative x direction, right? So if we talk about case A, so let us assume the force on the wheel. So let us assume force on wheel in positive x direction. Let me assume the force on the wheel is on positive x direction. This is the force on the wheel. Force on the wheel, let us assume it is on, force on the wheel is on positive x direction. Let me call this as Fx. That is my assumption. So if the force on the wheel is on positive x direction, and who is applying the force on the wheel? Force on the wheel is applied by the fluid. So it means the momentum of the fluid in positive x direction will be less than the momentum of the fluid in negative x direction. So momentum of the fluid at B will be less than momentum of the fluid, angular momentum I am talking about, angular momentum of the fluid at A. So we can say Fx will be equal to, the force exerted will be equal to P dot A minus P dot B, the force exerted on wheel, is equal to PA dot minus PB dot. Because fluid will experience a force in negative x direction. Now if we are getting Fx to be positive, it means our assumption is correct. If we are getting Fx to be negative, it means our assumption is incorrect. So if we talk about case A, case 1, if we talk about the case 1, what is Fx, what is P dot A? That is rho into QA into VA minus rho into QB into VB. Or we can write it as, look, that can be written as rho into QA VA minus QB VB. If we are getting this as positive, this is our basic analysis. This, if we are getting it as positive, it means our direction is correct. If we are getting it as negative, then our direction is incorrect. So for the first case, if we talk about case 1, for the first case, we can say Fx is equal to rho, then QAVA minus QBVB, and case 1 says QA is equal to QB, and if QA is equal to QB, then what do we get? In case 1, what did we get? QA is equal to QB, then VB is equal to twice of VA. VB is equal to twice of VA. That is what we got. So are you getting it as positive? QA and QB. So rho into Q. Q is equal to QB. Then VA minus VB. Are you getting it as positive or negative? VB is greater than VA. So it is negative. It means our direction is incorrect. So our direction is incorrect. So Fx in first case, Fx will be on negative. So the motion will be in negative x direction. Motion will be on the left hand side. In first case, if we talk about case 2, then VA is equal to VB. So we can say if VA is equal to VB, VA will be equal to VB, then QA is equal to 2QB. QA is equal to twice of QB. That is what we got. So Fx will be equal to here rho into V. Then it will be QA minus QB. Here QA is greater than QB. So it means it is positive. It means positive means our direction is correct. It means force on the wheel is on correct direction. That is, it is moving on the right. So in second case, it will be moving in the right hand side. In the first case, it will be moving on the left hand side. Do you understand it or not? Do you guys understand it or not? In the first case, it will move towards left P, and in the case 2, it will be moving towards right S. P and S are correct. P and S are correct. Option A is the right answer. I hope you understood this. Hi Achu, क्या आपने अपना नाम बताया? रवि रंजन राजपूत. Welcome Ravi Ranjan. Good evening, good morning. Welcome to the session. So did you guys understood or not? So there are some assignment question. You should try these questions at home and bring me the solution. Share me the solution through WhatsApp or through Telegram channel. If you want to be part of my WhatsApp group, you just request for it through the Telegram channel. And if you are not part of my Telegram channel yet, do join me on the Telegram, Mechanical by Chandrasekhar. We are starting formula memory test very soon from 25th of October, where we will make you revise all the important formula from each and every subject through an interesting manner. This is the schedule for the formula memory test. That session is going to be conducted on our BYJU'S YouTube channel. So you just have to subscribe our channel. This is question number 9 and 10. This is again assignment. Question number 9 and question number 10. I will share the PDF of this session to my Telegram channel. Do practice these questions. They are wonderful. That will help you to improve your fundamentals. We are running the GATE 2024 crash course also. We have started the GATE 2025 and 2026 long-term batches as well. So you just call the mentioned number for better clarity about our various paid courses. That is all from my side. Tomorrow at 6 p.m. I will be coming live for the real flow. I hope you guys understood and you enjoyed thoroughly this session. So see you tomorrow at 6. Till then, enjoy. This is the series 10 Kadam we have discussed. Tomorrow will be the last session. If you have not attended the previous session live, do watch the recording. Do not forget to watch the recording and do not forget to try solving those questions independently again if you have even attended the session. So that is all from my side, guys. Thank you very much for joining in. Take care. These are the details for my Telegram channel. Thank you. Jai Hind. Stay safe. Stay motivated. See you tomorrow at 6. Thank you very much once again.